In this video, we are going to be finding probabilities for normal distributions. We have x is distributed normally with a mean of 40 and a variance of 3 squared, which means the standard deviation is 3. So remember our normal distributions like a bell-shaped curve. The mean is in the middle. And most of the data, 99.7% of the data, is within 3 standard deviations. 95 is within 2 standard deviations, and 68% is within 1 standard deviation. But we need to find the probability that x is greater than 35 now. So greater than 35, that means everything on this side. We're going to use the calculator to work it out. So if we look at a calculator, I'm going to press Menu, Distribution, and Normal CD, Normal Cumulative Distribution. We need to put in a lower and an upper. So it's everything bigger than 35. The lower is 35. The upper, we have to put in something. So I'm just going to put in a really big number. Remember, 99.7% is within 3 standard deviations. So that would be up to 49. If I put in a massive number, it's going to essentially include everything. The standard deviation is 3, and the mean is 40. So press equals, I get 0.952. So that is the answer. Find the probability that x is less than or equal to 38. We could ignore the or equal. That's the same as x is just less than 38. Because it's continuous data, less than or equal or less than is going to be the same. We are going to put in our lower as a really small number. I'm just going to put 0. I could use a negative number. The upper is 38. Our standard deviation is still 3. Our mean is still 40. And we get 0.252. And the probability that x is between 38 and 45. So this time, we're going to put the lower as 38. The upper is 45. And we're going to keep our mean and standard deviation as they are. We've got 0.6997, so 0.700. Okay, one for you to try. See if you can give that a go. So this time we've got a mean of 8.2 and a standard deviation of 0.9. So normal cumulative distribution, we want the probability that x is greater than 9. So 9 is our lower. Our upper, just put in a really big number. We have our standard deviation is 0.9 now, and our mean is 8.2. So we get 0.187. The probability that x is less than or equal to 8. So that's the same as less than 8. So we're going to put our upper as 8. We're going to pick a really small number for the lower. And our mean and standard deviation stay the same, 0.412. Let's just look at that number we put in for the lower quickly. So if I put in 0, I would have still got 0.412. If I put in 5, I would have still got 0.412. But I think any more, it would have not been 0.412. So just put in a really big or a really small number when you're doing that. You could just use minus 10,000 and you're going to get a more accurate answer. Find the probability that x is between 7 and 10. So the lower 7, the upper is 10, Our standard deviation is 0.9. Our mean is 8.2. We get 0.886. Here we have another question. The heights of 10-year-old children are normally distributed with a mean of 139 centimeters and a standard deviation of 5 centimeters. Find the probability that a 10-year-old selected at random has a height greater than 145 centimeters. So it's just a case of typing it into the calculator. So I'm going to distributions, normal cumulative. 145 is the lower. For the upper, I'm going to type in a really big number. A lot of standard deviations above the mean. The standard deviation is 5 and the mean is 139. I get 0.115. So that's the probability that a 10-year-old selected at random will have a height greater than 145 centimeters. Part B, we've got 20 10-year-old children being selected at random. Find the probability that 3 or more have a height greater than 145. So this is a binomial distribution question because every child can either have a height greater than 145 or not have a height greater than 145. So X is distributed binomially. There are 20 children and the chance of each one having a height greater than 145 is 0.115. So we can type this into the calculator. We want the probability that X is greater than or equal to 3. When we're using the calculator, it always gives us the probability of less than or equal to. So that's the same as 1 minus the probability that X is less than or equal to 2. So I can just type this in. I'm going to distribution again, but it's binomial cumulative distribution this time. Variable, X is 2, N is 20, and the chance of a success each time is our last answer, which is 0.115. I've got 0.591. So it's 1 minus 0.591, which is 0.409. One question for you to try. See if you can give it a go. So this time we've got 6-year-old children. The mean is 115. The standard deviation is 4. And we want the probability of greater than 110. So I'm going to go to normal cumulative distribution. The lower is 110. The upper is a really big number. Standard deviation is 4. Means 115. And I get 0.894. 0.894. For part B, we've got 20 children selected at random. The probability that 14 or more have a height greater than 110. So we're going to have a binomial distribution. 20 children, and the chance each time is 0.894. We want the probability that X is greater than or equal to 14, which is going to be 1 minus the probability that X is less than or equal to 13. So I'm just going to type this in, going to binomial cumulative. For a variable, X is 13, N is 20, and I'm using my last answer, 0.8943. So the chance, I've got 3.27 times 10 to the power of negative 3 So it's 1 minus 0.00327. So 1 minus that, 1 minus the answer, 0.997. 0.997.